seems it works. Hello, everybody. Briefly, what we planned, what we achieved. So most of the things we planned, and some of them were achieved. What worked well for us, likely everything what was related to recommender engine. Maybe first question, could you please raise hand who knows what's recommender engine, what it serves for? Okay, well, I think then I won't explain. In general, everything we tried on worked. What was a little bit of a challenge, I'll skip this slide, go this slide very quickly to go for more interesting things. The things which we wanted to try in Azure, in OpenAI and Azure AI search, we simply didn't have time for, but we used the LLM for creating embeddings, and also speaking of data sources, the data of the users, we simply didn't have time to process. They were not of a high quality. And maybe on this slide, last but not least, I wanted to say thank you to the guys from my team and also to organizers. It was actually a lot of help from their side, especially from Dan. Thank you very much. So now about the recommender engine, what we actually tried on. In general, the ambition was to build production-ready recommender engine. You probably have heard of OnePlay, and we wanted to build a challenger which can be deployed, let's say, next week. Speaking about the rec engines, we tried three approaches. Let's say the base one, the most safe, is a collaborative filtering. Second one was a little bit more tricky, and it's based on word-to-vec. And in a minute, my colleague will tell you what exactly worked, how it worked. The third one was based on the embeddings created by LLM. Those embeddings were on top of the descriptions of the titles. And the last one, which we also simply didn't have time to finish, was based on deep learning and content filtering. And the last one was a little bit promising from the viewpoint of cold start, especially for users who have no information about their preferences. That's about the engines. And speaking about the data, we used the production data. So you can imagine that was actually the hardest part. We've chosen last half a year, and this something like 170,000 users who watched in total roughly 2,000 shows, and that's 19 million views, so almost 20 million views. Speaking about the evaluation of the models, because for Rec Engine it's a little bit tricky. Like the ultimate test will be A/B test, but we cannot do it on hackathon. So how to evaluate it? One approach is like very plain and simple. It's just intersection. So we've chosen the top users who are the most watchers on the platform, and then we took apart 1 month, the last one, and made recommendations and just looked in the intersection of the recommendations and their actual usage. So that's like kind of A/B test, but no A/B test because there are no A/B groups. And second one, it's something which we thought maybe the future is using as LLM as a judge. We simply created same results, but then we feed it to the LLM and asked, okay, please judge which of the three models give the best results. And you can actually see that word-to-vec won in terms of intersection by a large margin, and in terms of LLM as a judge, it was second best, and there the embeddings were the best. Maybe at this moment, I will give a word to Evgen. He will explain how this word-to-vec worked, because maybe for some of you it will not be so trivial.
Yeah, thank you. So one of the used models to learn these content similarities was word-to-vec. And as you may think, it probably works with text, but no, not in this case. Maybe some of you who worked with language processing may know this algorithm, and please raise your hand if you know it, word-to-vec. Okay, so I will briefly explain it. It's usually used to find embeddings for some words, and embedding is basically a vector that just is assigned to each word, and it is learned in a way that words which have similar meaning have vectors close to each other. So let's say we have dog and cat, and they are quite close, but let's say kangaroo and luggage are pointing in different directions. But here we didn't use it for text, but usually it is trained that we are sliding through some text, and when we have like we are training on close words, and So that's how we get it, these embeddings. But here we trained it instead of sentences on sequences of IDs of watched content. So let's say instead of sentence, we have a sequence of movies watched by some user. It's our sentence now. And in a similar way, when we have some movies that appear in this sequence often close to each other, it means that this content is similar. And in this way, we can learn these embeddings by using algorithm, which is mainly used for text, but we can use it for a completely different purpose. So I believe that's all. That was some fun fact, and surprisingly, this unusual way to use it turned out to be quite good, and we had good results with this algorithm. Thank you.
Thank you. We can talk about a bit later after the presentation how exactly it works, but it's very straightforward. So also we wanted to show some how did we make this test? So one of the examples, so we've chosen the user. We've seen, I guess, in total something like 10 movies in the 6 month movies or series. We also have series. And for this user, we generated recommendations, and then we just simply see the intersection. So how many hits do we have? And you see that word at the most hits, but that's exact this word match or the title match. So it's exactly the title we recommended him. He happened to watch even without recommendation. So that's kind of quite a strict test. We will go to AB, probably it will be something, hopefully more hits. So that's in a nutshell about the model. So we tried 3 of them. 4 is, let's say, 75% finished, but there's still way to go. Now speaking about the architecture, we were partially at certain advantage because we already use Azure, so all the data we had ingested, and we have all the permits, connections, and so on. Maybe what was quite challenging is that we're using really production data, and you've seen that's 19 million views, so some transformations run for 3 hours, and that's actually was the most time we've spent just staring to the notebooks how the things are going. In general, inside Nova, that's probably some of the story behind. We use as a storage BigQuery, so some of the data they get into BigQuery. So for modeling, we get it from BigQuery to Databricks data catalog. There we use delta tables, and based on data tables, we do ETL, and then on top of it, we train the model. And actually, with Word2Vec and with collaborative filtering, it was quite easy because Databricks has its own packages, so it was quite efficient in terms of time. And then for serving, we could stop there, simply have a database and then expose it to the provider of the one plane. Another option, and we wanted more to present it to the internal management of the company, that we can also serve it via API. So we use the Cosmos DB with Azure functions on top of it, and then you simply call the Azure function, it returns you the JSON recommendations. It can be used either by developer to test, or it can be used straight away by the application. So now the interesting question, if we have that much data, how much it costs and how fast it works. So we tried maybe, I don't know, maybe 40 minutes, maybe 1 hour of different tests. So actually Azure allows this as well. So a little bit of promo for Azure. You can design this test, and you can design how much of the data you want to flow inside. So we had to also not to spend too much money. We had 4 or 5 minutes tests with different scale of the Azure function and the Cosmos DB. And you can see that basically, okay, the response time was between 1 second to 33, 33 seconds. So not so great, but it was really, really cheap Cosmos DB and all very cheap Azure function. So I guess for production use, we will come with something bigger. But in general, we've shown that in practice with this amount of data, we can do it in 2 days. And now a little bit of demo.
Yeah. We have a live demo ready to go, but it will take literally 1 second. Just so you would believe us that we actually created something that is usable. So as Standa mentioned, As Tanda mentioned, we are using CosmoDB, and we are also using Azure Function to create a simple API, which only has one endpoint, that is to get the recommendations from a user based on a user ID. Once I hit this endpoint, then we should see a list of recommendations of recommended movies. There will be 10 movies available. Yes, so the encoding is a bit dodgy, but yeah, we can see that for the user 49 and so on, we have the Assassin's Creed, Black Adam, and so on. So yeah, I can, yeah.
Sure, the endpoint is deployed, but you need the API key. So if somebody wants to test it right now, we took care of it because we have head of IT here.
Basically, we ran a couple of, thank you very much. We ran a couple of load tests, so it was really cool for us. The guys from PwC helped us quite a lot with this, I would say. And I suppose so. We are using the CosmoDB, and once we scale it to its limit, which is about 1 million resource units per second, then we should be able to cover the highest peaks that our platform has, I suppose. So it looks that way. So I suppose our solution would be sufficient for anyone to use once we scale it. So the barrier to entry also, if somebody were to integrate our solution, they could just, rise through our endpoint and then hit it, get the results back, and they could be presented straight away in the app.
Yeah. So I guess that's it, folks. Our idea was to try in 2 days to build and deploy the recommender engine. So we kind of did it. Of course, it needs a lot of improvement and also it needs integration, but in general, there's the results, and we will be happy to discuss it after presentation. Thank you very much. There's no questions. That's it.
Maybe how much data did you train the word-to-vec model on? Roughly.
Half a year of data. So that's
Yeah, it was half a year. So basically, it was a sequence of watched movies for every user. And there was like several hundreds of thousands of users. And I don't know how much of movies on average per each user, but like
A lot.
100, I would say.
30 millions per month or something.
But you can imagine it's just a user and he's watched shows, and you have several 100,000 users like this.
Actually, it was a bit of a challenge that some people, they watch just two soap operas and nothing else, and what you can recommend. So that was the third one, which is left. That was one of the things, and another, I think the champion which we've seen, he watched the guy.
Something like
2000 episodes in half a year. So basically, we calculated it something like 30 or episodes per day. So no personal life. He's just it's just some TV running in some.
probably TV shot or account shot. So that will be another one.
Of course, it
it could be the TV on our reception. It's running nonstop. So perhaps, yeah.
One question, sorry, if I may. How did you come up with the idea to use the word like in the setup you?
Well, actually, to be completely honest, that was an idea of our colleagues from Romania, and they made it there. And then I thought, really, it's like usually these the smartest idea. There's so much obvious when then you're told. You say, why didn't I come up with this before? But that's so nice usage. We just wanted to try it out, and it turned out to work the best.
So important knowledge.
Yeah. Also important to share because I personally have heard it from them in one of the events like this. So someday, tomorrow Netflix will deploy something like this.
You said that, but in the next steps, are you satisfied with what you found out? Will you pursue it to the production with what you found out, or was it unsatisfactory?
I had a call yesterday with our guy from CME from the mother company, and he's very active guy. So his idea was to make A/B test next week. So I don't know. So we will see. We will see. I can.
Yes.
If you'll get some weird recommendations on one play, I don't know if any of you have subscriptions. You know whom to call and whom to believe.
We'll see it in production in 2 weeks. Yeah.
The platform stable. No, no.
Yeah, sure.
The idea of that hero subscriber here, Michal, is that it was some kind of a thief of the media content. Are you
They share the account.
not sharing the account, but
Like
downloading it, transcribing it, not transcribing it, converting it, and then sharing to some other networks? Are you protected
Actually, yeah, that's
in that model and against those?
like right now when you told me, I think we don't have any this fraud detection models at all. So, and it can be actually it's a good use case. Actually, it's pure, it's simple statistic. I'm not sure. Maybe it's done because we don't do these things. I think it should be done by sales department at least. Just yeah, but it's a very interesting idea to use this anomaly detection to see if something fishy is going on.
Thank
you.
Thank you.